Hi, this is Mark here from Phase Change Converters. I'm just going to introduce you to the phase driver system that we manufacture. This is a single phase to three phase converter box which is used to run three phase motors, so three phase 415 volt motors from a 240 volt supply, so single phase 240 volts. Now, the reason we want to do this is that if we have single phase 240 volts, we can then put a standard UPS, so uninterruptible power supply, single phase one for relatively low cost on it, and we can give you guaranteed backup on the supply. So if your mains voltage drops out or your supply drops out, the UPS takes over, and that single phase 240 volts coming into this system will keep the door or the motor operational, in fact, for quite a long time. So at the moment I've got this system just running on the mains 240 volts, so I just want to run through what it does. So here we have the phase driver. This is the standard little phase driver, 1.1, so it's up to 1.1 kilowatts, and it's a 240 volt in, 415 volt three phase out the other side. This is the standard Grifco eDrive system. This is a three phase unit, so this one here is 0.75 kilowatt. So 1 horsepower, eDrive system with the door control, with the programmable limits and all the rest of it on it. Now what we're doing is we're going to interface this into it. Now it's very straightforward. All we have here is 3 wires coming in, which is your 240 volts. Now we've just got that plugged into a power point, but of course that could be plugged into a standard UPS. So we recommend the UPS around about that 1600 VA mark on this one, which we carry if need be. So the single phase just comes into those first terminals. We then have 2 conduits, 2 separate lines coming out. So one is here, we have a 240 volt control output. Now that control output actually goes up to the eDrive control board and it supplies power to the eDrive. So we have a brown and a blue there going into the out 240 volts and out neutral, and they just come up into the eDrive, into the neutral terminal there, and the L3 terminal there, and of course we've got an earth, which is earth there. There's 2 more wires, and there's 2 wires that we actually pick up from where the motor was originally connected to. So this will become our up and down signal commands. So we have a terminal on X, so X is this one here with a mark on it, and Z. The X terminal goes down into here, which is our up input 240 volts. We also have a down input 240 volts, which is connected at the other end to the Z terminal. That's it. That's as far as the control goes. That's all we need. Now, the motor, separate issue. The motor we connect to the U, V and W terminals, which is effectively the output of the VSD internally. We put that in a separate conduit only because there's potential using a VSD of electrical noise. So we want to just keep it isolated. So we've run that up, and what we do on this one, I find it's easy just to pop out the little 20mm plug that's in the side of the eDrive, which is right where the 3 wires would have been plugged on to the terminals originally, and push those wires. You might have to flick the board up, but then push the wires into a junction box so your connections are outside the board. What I don't want is to see 3-phase connections made in this area around the antenna or any of the microprocessor stuff. That's the potential for noise, which could give you erratic or faults in the operation. So we bring up the 3 wires. So 3 wires simply is U, V and W, which is in this case our brown, our black and our blue connections going through. That is as simple as it gets. Now, as far as the operation goes, it's exactly as it would have been. The control system's designed to operate as a 3-phase or 240 volt system. We can operate this as a 240, so we're operating the control system as a 240 volt, and what we're doing is we're rerouting the 3-phase motor so that it comes via the VSD, which we are creating 415 volt 3-phase out of, right, from a 240 volt supply at this end. As far as controls go on the Grifco goes, it doesn't make any difference as to whether you've got light barriers or safety edges or interlocks, key switches, keypads, card readers. It doesn't make any difference. This will operate exactly as it was originally designed to operate, and all the interfacing. All we are doing is changing the way that the motor is routed. So effectively in this situation, the three-phase Grifco system no longer needs three-phase supply. What we will be supplying it permanently with is a straight 240 volt supply only, right? Which is then sent into our phase driver box. 240 volts is then sent back up to the Grifco unit. We get two signals back for the up and down, which comes back to our phase driver box, and from there it tells the motor which way to go and when to go. It's as simple as that, and of course the beauty is it can all then be plugged into a UPS, and that UPS will provide the backup in the case of powers out. So for critical applications, personnel safety, anything like that, it is ideal for those type of applications. So there's the introduction. The phase driver, really simple, very straightforward to install. One other little advantage, of course, being with the VSC, we put a very short ramp on it, so we take out some of that initial shock on the startup as well. So, yep, there it goes. Okay, thank you.